Yeah. Good afternoon to all of you. Good afternoon, students. Am I visible and audible to all? Can you see the screen? Just let me know in the chat box if I'm visible and audible to all of you. So just type yes in the chat box or just tell me whether you can see the screen or not. Yes? Okay. Thank you so much, Sujan. So, in the last class, we have discussed about the P block elements, right? That is from group 15 till 18. So last class only we have started this lesson. And as I have told you, we are discussing the basic concepts of group 15 elements, physical, chemical, and anomalous behavior of nitrogen. And in the last class, we have completed the first topic. That is, we have completed all the basic concepts of group 15 elements. And we have discussed some of the physical properties of group 15. Like we have discussed the electronic configuration. We have discussed the electronic configuration of group 15. And we have discussed the atomic radius of group 15 elements and ionic radius. And we have discussed what is ionization energy and its trend. And at last, we have discussed what is electronegativity, right? And its trend. So these 4 physical properties I have discussed with you in the last class. Now in today's class, let's continue with some more physical properties and then we will shift to chemical properties. Okay. And as I have told you, the major part of this lesson is deleted, which is a very, very happy news and good news for all of you guys. Okay. So you have to study the part which is there clearly and properly. You should not leave. You should have to study every nook and corner of this lesson. Okay, because only very few topics which are very easy are included in your syllabus in both JEE and NEET. So you concentrate more on this topic and study. It is going to be very easy for you. So let me continue with the 5th physical property, which is called the metallic and non-metallic character. Okay. So who are the group 15 elements? Can anyone let me know in the chat box the 5 and or 6 elements of group 15 by giving their symbols? Can anyone type and show me the symbols for all the elements of group 15? Okay. It is nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium, right? Moscovium. So these are the 6 elements, and moscovium is radioactive, I have told you. And the symbol is also given to you. And the first 2 elements are non-metals, second 2 are metalloid, and last 2 are metals. This part we have already discussed in the basic concept. While I was discussing the basic concepts of group 15, I have told you and I have shown you this slide. Okay. Now, what is the trend? What is the trend of this metallic and non-metallic character? So you can see from the slide, the metallic nature on moving down the group, it increases. On moving down the group from top to bottom, we all know that atomic radius increase, right? And also we know that atomic radius and ionization energy are inversely proportional. So if atomic radius increases, obviously ionization energy will decrease, right? If ionization energy decrease, metallic nature will increase. Metallic nature will increase. So what is the relation? Atomic size is directly proportional to metallic nature. Atomic size is directly proportional to metallic nature. If atomic size increases, metallic nature also increases. You can see it is moving from non-metallic character to metallic character, right? So this is the trend of metallic character. Now, non-metallic character obviously is the opposite. When metallic character increases, non-metallic character decreases. That's all. Very simple and easy. And in the exam, you have to be very clear, like they may give you the 4 elements and they will ask you to find out the only metal in the given 4 options. Or they will ask you to find out the only non-metal. or they will ask you to find out the metalloid. Okay, so like that, questions will be asked from this particular part. So this is about the metallic and non-metallic character physical property of group 50. Okay. Now moving on to the next physical property, it is about the physical nature or the physical state of all the 5 elements. Since the last element is radioactive, so it is having only a very short half-life, and there is nothing much to study about it, and we cannot define the state of that last element also. Okay, so let's discuss the property and the physical nature of the first 5 elements. Those are nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. Now coming to the first element, the physical state of nitrogen is gas. Physical state of nitrogen is gas. So nitrogen is present in a gaseous form in the atmosphere. You can see nitrogen cylinder in the picture. Okay. And coming to phosphorus till bismuth, they are solids. From phosphorus till bismuth, they are solids. Red phosphorus and arsenic, antimony, bismuth, everything you see, they are existing in the solid. Okay, no liquid is present in group 50. That is the point you are studying from this. Clear? This is about the physical state of the group 15 elements. Now, next I'm going to ask you one question from the last class, that is from the ionization topic. I hope you guys would answer for this. So try for the thing and let me know the answer in the chat. So why ionization energy of group 15 elements is larger than group 14 and group 16? I'll give you 30 seconds. So try to answer for this question. Give me the answer. So what's the reason for the more ionization energy value of group 15? Can anyone try for this and put the answer in the chat box? Very good, dear. Very good. Manikanta, it is good. Because of the half-filled configuration of group 15. Yeah, because of the half-filled configuration of group 15. You can see the configuration is, for example, if it is nitrogen, it is 2s2 and 2p3, right? And for group 16, you will have 2s2, 2p4. Half-filled configurations are more stable. Half-filled configurations are more stable. So the energy required to remove the electron from the more stable configuration is more. Okay, that's why the ionization energy of group 15 is greater than the ionization energy of group 16. Very easy question, but very important. Okay, so with this, the physical properties of group 15 is getting over. Now let's move on to the third topic, which is the chemical properties of group 15 elements. Okay, so under chemical property, the first property that we are going to discuss is oxidation state of group 15. So the very most common oxidation state, you can see it is -3, +3 and +5 for this particular group. And nitrogen, you can see it can show oxidation state from -3 to +5. -3, -2, -1, like that, it can exist till +5. And phosphorus, you can see there are only only three oxidation state possible for phosphorus, which are the common oxidation state, that is +5, +3 and -3. And arsenic, for that it is only 2, +5 and +3. Antimony also the same case. And bismuth, you see there is only one state. It can exist only in one oxidation state, that is +3. Okay, so this is the oxidation state of all the given elements. Now coming to the nitrogen story, nitrogen doesn't show +5 oxidation state with halogens. So who are halogens? Fluorine, chlorine, bromine and iodine. So nitrogen will not combine with any of these halogens to give the +5 oxidation state. Okay, like it will not exist in NCl5, or it will not exist in the form of NF5. So this kind of compounds are not possible, because in all these compounds you can see nitrogen is in +5 oxidation state. So such system is not possible. Only NCl3, NF3, they are possible. So nitrogen will exist in +3 oxidation state with halogen, not in +5. Okay. And +1 to +4 oxidation state containing compounds undergo disproportionation reaction. What is disproportionation? In the reactant side, an element can exist in an oxidation state, but in the product side, the same element will be oxidized in one of the product, and the same element will be reduced in the other product. That reactions are called as disproportionation. So if a nitrogen is present in +1 or +4 in your reactant part, it will be getting disproportionate, okay, in the product. And one more point about the nitrogen is +1, +2, +4, +5 oxidation states are possible only with nitrogen. In case of NO, in case of NO, the oxidation state of nitrogen is +2, right? Because oxygen is -2. And if I take nitrogen as X, you will get +2. So the +2. And then the N2O. In N2O, what I will have? 2x minus 2 is equal to 0, and x is equal to +1. So in this compound, I am having +1 as the oxidation state for nitrogen. And in case of N2O4, in N2O4, it is 2x minus 8 is equal to 0. So here you will get +4. Okay. And in N2O5, 2x minus 10 is equal to 0. So x is equal to +5. So here it is +5. So these particular oxidation state for nitrogen is possible only when nitrogen is bonded with oxygen, not with other elements like halogens and other elements. Okay. And coming to the, before moving on to the phosphorus story, some more points are there for you, which is the covalency concept. Yeah. So the covalency, maximum covalency of nitrogen is 4. Like in case of NH4 plus, you might have seen. So NH4 plus. So in this compound, nitrogen is having 4 bonds, right? So nitrogen can have only 4 bonds with it. Maximum covalency is 4 for nitrogen. Okay. And the elements in +5 oxidation states are oxidizing agents. Like we have seen on example just now, right? N2O5. In N2O5, the oxidation state of nitrogen is +5. Now this N2O5 is a strong oxidizing agent. It is a strong oxidizing agent. So all the compounds in which the nitrogen is in +5 oxidation states are oxidizing agents. What is an oxidizing agent? Electron accepting reagents. So this N2O5, it will go and accept the electron from the species to which is getting reacted. It will go and it will take the electrons from this atom and it will have it. Okay, electron acceptors. Fine. Now coming to the story of phosphorus. Phosphorus, majorly they form oxoacids. What are oxoacids? Oxygen and hydrogen containing phosphorus compounds. Like we have H3PO2, H3PO3, H3PO4. So all these compounds contain oxygen and hydrogen, right? So this is called as hypophosphorus acid. This is phosphorus acid, and this is phosphoric acid. Okay. So all these are oxoacids of phosphorus, in which the oxidation state. So in case of H3PO2, what is oxidation state of phosphorus? So take this phosphorus as X, and for each hydrogen it is +1. Since we have 3 hydrogen, it is +3. So +3 plus X. So 2 into -2. So it is -4 equal to 0. X is equal to 4 minus 3, which is equal to +1. So in case of H3PO2, the oxidation state of phosphorus is +1. So like this, you can calculate for the H3PO3 and PO4 also. So it will have from +1 to +1. So they form oxo acids in +1 and +4 oxidation state. Okay. Now coming to the bismuth story, it does not form +5. You can see it can form only +3. Can form only +3. So the stability of lower oxidation state increases on moving down the group. The stability of lower oxidation state increases on moving down the group. So only the lower oxidation states are more stable when we move down the group. What is the reason for that? Why the stability of lower oxidation state increases on moving down the group? It is due to the inert pair effect. The reason is inert pair effect. What is inert pair effect? The inability of s electrons to participate in bonding due to the increased nuclear charge is called as inert pair effect. So I'll explain you more clearly. Just listen. On moving down the group, number of the shells increases, right? On moving down the group, number of the shells increases. Okay. For example, so the nitrogen will have only 2 shells because it is a second period element, and phosphorus is a third period element, arsenic 4 and antimony 5, and bismuth is having 6 shells. So let me draw the atom of nitrogen. So this is a nucleus of nitrogen. This is a first shell of nitrogen. This is second shell of nitrogen. If this is phosphorus, third shell will be there. Okay. And also, we know that the general electronic configuration of group 15 is NS2-NP3. NS2-NP3. Right. Now, on moving down the group, the number of the shell increases. For phosphorus, we have only 3 shell. If it is antimony, how many shell we will have? This is a nucleus. Shell number 1, shell number 2, shell number 3, shell number 4, and shell number 5. So for antimony, we have 5 shells. So number of the shell is increasing. The addition of d electron and f electron also increases on moving down the group. Because only from this phosphorus, before this phosphorus only we have, not phosphorus, before this arsenic only we have d block element starting. Right. So the d electrons will be filled, d orbitals will be filled only for the elements which are just before this arsenic, not before phosphorus or nitrogen. There we do not have d orbitals at all. Okay. And coming to antimony and bismuth, we will have f electrons also. Now, these d electrons and f electrons which are there inside this, for arsenic and antimony and bismuth, they are ineffective shielders. They are the ineffective shielders, means they have very poor shielding effect. They are having very poor shielding effect. Let me explain you. So if this is antimony, the outer electronic configuration will be 5s2 and 5p3, right? In the fifth shell, we have 2 electrons in s orbital and 3 electrons in p orbital. Now inside this shell, we have 4th shell. In the 4th shell, we will have 4 d orbital, and inside that we have 3rd shell. In 3rd shell also we have d orbital. In 3rd shell we have d orbital. In 4th shell we have d orbital as well as 4f orbital. Okay, we have 4f orbital. Now there will be electrons which is there in the d orbital and f orbital for antimony. So those d electrons and f electrons which is present in that particular shell will not shield the outermost electron properly. Okay, they will not shield the outermost electron properly. So I'll show you more clearly. So here is our 4th shell. This is the 3rd shell. This is the 5th shell. So in the 5th shell, we have 2 electrons in s orbital, right? And 3 electrons in p orbital. So these electrons which are located in the 3rd and 4th shell, they will not shield the valence electron, that is outermost electron, properly. So what happens? The electron which is there in the s orbital, it will get attracted towards this nucleus. Okay, since the shielding is not good, these electrons are not shielding properly, so there is a gap. So the outermost electron can get attracted towards the nucleus more effectively. Got it? So attraction happens. So only the 3 electrons which is there in the p orbital, the 3 electrons which is there in the p orbital can take part in the bonding with the other elements. Only the electrons which is there in the p orbital, 3 electrons in the p orbital can form the bond with the other elements of other compounds. Okay, they can give only 3 electrons, or they can share only 3 electrons. They can form only 3 bonds. So that's why bismuth is stable only in +3, and antimony is stable only in +3 than +5. So this is the reason for the stability of the lower oxidation state on moving down the group. So the s electrons, they are unable to participate in bonding due to the attraction towards the nucleus because of the poor shielding of d and f electron which is present inside them. Whereas in case of phosphorus, we don't have the d orbital and the f orbital, no. So there is no shielding. D electron, f electron shielding will be there. Only p electron and s electron will be there. In case of first shell, we have only 1s. In the second shell, we have 2s and 2p. In third shell, we have 3s and 3p. So inside this third shell, only 2 shells are there, in which we have only 3s and p. So s electron and p electron, they will shield very effectively. Got it? So what happens? All the 5 electrons can be donated. All the 5 electrons from the outermost shell can be donated. So that's why nitrogen, phosphorus, they are having +5 oxidation state, but bismuth is having only +3. Inability of s electron to participate in bonding due to the increased nuclear charge. Increased nuclear charge is nothing but the number of electrons or the protons. Nucleus charge is getting increased by adding the electron. Nuclear proton count also gets increased. No, that is the nuclear charge. So as the atomic number increases, stability of lower oxidation state becomes more stable. That's all. This is your inert pair effect. Got it? So because of this inert pair effect, I told you stability is more for lower oxidation state. Nuclear charge towards the valence electron gets decreased, and the stability of +5 oxidation state decrease, or we can say the stability of +3 oxidation state increases on moving down the group. Clear for all? Inert pair effect. If you're having any doubt in the inert pair effect, you can put it in the chat box, or if it is clear to you, just type yes in the chat box. I will move on with the next topic. Shall I move on with the next slide? Yes or no? Go through this concept again, you will get. Okay, you will get it. Still, if you're having any doubt, ask me in the next class. Yeah, okay, Namita. Good. Thank you for your response. Now I'll go with the second chemical property. So first, commonly or generally, we have seen about the oxidation state. Now coming into the general chemical reactions of group 15 elements. So all the group 15 elements can react with the metal. They react with the metal, and they react with hydrogen, and they react with oxygen, and they react with halogen. So all these reactions can occur for group 15 elements. Okay, and especially talking about, I will discuss each and everything now separately. So these 4 are the chemical reactions for group 15. And specifically talking about the reaction with metal, group 15 elements show -3 oxidation state. Usually all the group 15 elements, they have plus oxidation state, no? But they will show -3 oxidation state and form binary compounds with metals. So you can see Ca3N2, calcium nitride, calcium phosphide, sodium arsenide, and zinc antimonide. In all these cases, you can see that nitrogen is having -3, and phosphorus is having -3 state. So I'll give you an example. Let me take Ca3N2, and we will try to calculate the oxidation state of this nitrogen. So nitrogen is taken as 2s, and we all know each calcium has +2 charge, right? Because it is a group 2 element. So all the group 2 elements will have +2 oxidation state. So since we have 3 calcium, So it is 3 into 2, which is plus 6 plus 2x, and it is equal to 0. So 2x is equal to minus 6 and s is equal to minus 3. Okay. So the oxidation state of nitrogen here is minus. Like this, you can calculate for other elements also. I'll show you one more thing. If I take this Na3As, arsenic is the group 15 element, right? So only one arsenic we are having. Let me take it as As. And sodium is a group 1 element. So plus 1 is the oxidation state for group 1 elements. So since we have 3 sodium, it is plus 3 plus x is equal to 0 and x is equal to minus 3. Okay. So in all these compounds, the oxidation state of group 15 is minus 3. So calcium, sodium, zinc, all these are metals. When group 15 react with metal, it shows minus 3 oxidation state. So that's about the first reaction. Now coming to the second reaction, that is with hydrogen. EH3 type hydrides are formed. EH3. That is, E means the element of group 15. Those are nitrogen phosphate like NH3, PH3, ASH3, those compounds. Okay. And the order of stability of hydrides are, this is the order of stability. NH3 is more stable than PH3, than ASH3. So what is the reason? You can see the reason above. So in case of nitrogen, we have 2p orbital as the valence shell containing orbital, right? So 2p orbitals are having double shape and it is overlapping with the hydrogen. It is overlapping with the hydrogen s orbital. And in case of PH3, we have 3p orbital for phosphorus. This is for NH3 and this is for PH3. And in case of arsenic hydride, it is this and this is the antimony hydride. Okay. So on moving down the group, the shell number increases. You can see the shell number increases. So the orbital size also increases. Orbital size also, the dumbbell shape, you can see it is increasing. But all the dumbbell shape containing p orbitals are overlapping with s orbital, which are having the similar size because all are 1s orbital only. Since all are hydrogen, all are having 1s orbital. And you can see the overlapping region, overlapping area is given in green color for you. Okay. Here, the distance, this is the nucleus. The distance between the nucleus and this overlapping region, you can see it is very less, or I can say the overlapping is to a greater extent in case of 2p and 1s. Whereas the overlapping is very less in case of 5p and 1s. Got it? So what happens? NH3 bond is, in NH3, NH bond is more stable compared to the SBH bond in SPH3. Okay. So, since the bond is more strong in case of NH3, it is very difficult to break that bond. So, we can say that it is more stable. It is more stable. It is very difficult to disturb. So, in other words, we can say it is more stable. So, the stability order for the hydrides of group 15 is this. So, the orders are very, very important. From inorganic chemistry, you can get questions from orders. Okay. So, which among the following is the correct order for correct stability order for group 15 hydrides? Or which among the following is the incorrect order for group 15 hydrides? What is the reason for the given stability order? Okay. So, like that they will ask. So, you should be able to answer. Okay. So, stability order is one of the very important order. And coming to the next is basicity. Basicity order is also to you on the screen. It is same as that of stability. So why NH3 is more basic? So what is the reason? Due to the small size of nitrogen, electron density is more. Okay, so it will act as an electron rich species. All the electron rich species are called as Lewis bases, right? Got it? So this is nitrogen, and these are our hydrogens. And the lone pair is located on the orbital. And when I come to phosphorus, nitrogen is this, and this is the size of phosphorus, little bit bigger than nitrogen. Okay, and this is the orbital of phosphorus. So you can see Here also we have 2 electrons, and here also in this orbital we have 2 electrons. But the 2 electrons are there in the small region, whereas here it is located in a large space. So where the availability of finding the electron in this 2p orbital is more. So this is acting as a more electron rich center, since the electron density is more. Space is less, so density is more. So NH3 is acting as a strong base. Okay. Clear for all? This is about the EH3 type of hydrides, in which you are going to study the stability and basicity order of hydrides. Very important. I will discuss about this with a question to all of you in the upcoming slides. Okay, don't worry about it. If you are not getting any concept, just let me know. I will explain again. Clear for all? So is the concept which we have seen today till this slide is clear to all of you? If it is clear, just give me a thumbs up or type yes in the chat box. We will move on to the next type of hydride of group 15. Shall I move on to the next topic? Yes. Thank you so much, Naira. Yeah. Now when the element, yeah, next type is reducing nature. Next type is reducing nature. So you can see NH3, PH3 till BiH3. And the structures are also shown to you. Now, what is the reducing nature of this hydride? Which can reduce more? Which can reduce more? NH3 or BiH3? The answer is BiH3. So why the reducing nature of bismuth hydride is more means the bond length of bismuth and hydrogen is more. This is the bond length order. If the bond length follows this order, why do the reducing nature have to follow this order? To understand this concept, you should know the definition of reducing first of all. Reducing means reduction. So what is reduction? Removal of hydrogen. So from which among these 5 hydrides you can remove the hydrogen more easily? It is from bismuth hydride, right? Because the bond length is more. If bond length is more, bond strength is very less. So this bond can easily be broken, right? So this hydrogen can come out easily. So this is the species which is giving off its hydrogen so easily. So it is giving out its hydrogen, the removal of hydrogen leading to the reducing nature of hydride. Okay, so that's why BiH3 is more reducing. When you see this NH3, NH bond is very strong, length is very short, and the strength is very more. So it is very, very difficult to break this bond. You cannot break this bond so easily. Hydrogen cannot come out so easily. So this molecule cannot act as a good hydrogen donor. So it is not a good reducing nature. BiH3 is having the good reducing nature among its hydrides. Okay, clear for all? So this is the third order you are studying, which is just the opposite of the previous 2 orders. Okay, for stability and what is the other one? Stability, and the other one is basicity, right? For that we have to follow the same order, and this is the opposite of those 2. Third order in hydrides. Now coming to the melting point and boiling point of this hydride, EH3 type of hydride. Talking about this NH3 is having the highest melting point and boiling point in both solid state as well as liquid state. The reason is hydrogen bond. You can see one NH3 molecule is forming a hydrogen bond with another NH3 molecule, right? So this dotted lines, those are hydrogen bonds. So that hydrogen bond is very, very strong. So only if all the hydrogen bonds are broken down in a molecule, a particular compound will boil or it will get melted, right? Since the bonding is very strong, it will take more time to boil or to get melted. So that's why the boiling point is more for NH3. Okay, the reason is due to the small size of the nitrogen and high electronegative nature of hydrogen. Because of its small size, it is able to form the strong hydrogen bond. Got it? Whereas the other hydrides from phosphorus till bismuth, they don't form strong hydrogen bond. Instead, they are having a type of force called van der Waals force. Only in case of NH3, we have hydrogen bonding as an interaction. In the other cases, we have van der Waals forces. That is very weak. Van der Waals force is very weak compared to hydrogen bonding. So comparatively, those hydrates are having very less melting point and boiling point compared to NH3. Now among them from pH3 till BaH3, you can see bismuth hydride is having the highest value. Bismuth hydride is having the highest value because this particular van der Waals force increases. If van der Waals, it is a kind of force like hydrogen bonding. If it increases on moving down the group, then bismuth hydride is having the strong van der Waals force, right? Compared to other. So we need to supply more amount of energy. Then only it will boil or melt. So that's why it is increasing. Okay. So first is NH3, then comes your pH3 till BaH3. So this is about the melting point and boiling point of the hydrates. And the next property is about the solubility. So NH3 is the most soluble due to hydrogen bonding in water. NH3, you can see they can easily form the hydrogen bonding with the water molecule. So they can get dissolved more easily. Okay? Within a very few fraction of seconds or minutes, it is getting dissolved in water. Whereas other elements, they cannot dissolve so easily. Okay. So this is about the reaction of group 15 with hydrogen. So how many reactions are there totally? 4. Reaction with the metal got over and reaction with the hydrogen also over. Now the third reaction is reaction with oxygen. So when a group 15 element reacts with oxygen, it is forming 2 types of oxides. One is of formula E2O5 and the other one is of formula E2O3. Okay, 2 different types of oxides with the 2 different formulas are formed. Element is your nitrogen 2 bismuth. Okay, now among these 2, one oxide is more acidic than the other. Can anyone tell me which oxide is more acidic? E2O5 or E2O3? Can anyone guess which oxide would be more acidic? Can anyone guess the more acidic oxide among these 2? Try for it. At least give a try. You guys are going to appear now for your exam in the month of January and May. So try your best. Which oxide is more acidic among these 2? Any idea? Okay. E2O5 Janani? Yes, good. That is a correct answer. So E2O5 is more acidic than E2O5 is more acidic than E2O3. Why? The oxidation state of the element in E2O5 is +5, whereas the oxidation state of the element in E2O3 is +3. So +5 means the element has lost all its 5 electrons. So it is electron deficient in nature. Whereas in case of E2O3, the element has lost only 3 electrons from its 5 valence electron. So it is comparatively electron rich. Okay. Electron deficient compounds are called as acids and electron rich compounds are called as bases. So that's why the element which is in the higher oxidation state is more acidic in nature. That's why E2O5 is more acidic. Okay, good. Now, on moving down the group, the metallic character increases. This concept we all know. And the metal forms the basic oxide, while the non-metal forms the acidic oxide and metalloids form the amphoteric. So we know that nitrogen and phosphorus, these 2 are non-metals and these 2 are metalloids. These 2 are metalloids, and the last one is the metal. And according to this statement, metal forms basic oxide. Means only the bismuth oxide forms basic oxide. Okay, bismuth forms basic oxide, whereas the non-metals, that is nitrogen and phosphorus, these two forms acidic oxide, and metalloids are amphoteric in nature. You can see here, these are the oxides of formula E2O3, and first two are non-metal, they are forming acidic oxide, and metalloid is amphoteric. Amphoteric means the one which can act as a base as well as an acid. And the last one is basic. Okay. Now, the basicity of oxides increases on moving down the group. From acidic, it is moving to basic on moving down the group. So, the basicity of these oxides increases, or we can say the acidity is decreasing. Acidic character is decreasing on moving down the group. Okay. So, the first two oxides are purely acidic. The second two oxides are amphoteric, and the last oxide is completely basic in nature. Clear? So I hope this is clear to all of you. So in the question, you can get like this. Which among the following is the only basic oxide from group 15 elements oxide? Okay. So you have to select the bismuth oxide. So this type of questions can be asked. Just read. That's enough. Nothing to do with the concept. Okay. So just read what is there. That is enough. Just kind of information only. These are all the informatory type of concepts only. Okay. This is about the reaction with oxygen. Then coming to the fourth reaction, last reaction of group 15, that is a reaction with halogen. And with halogen also, two different types of halides are formed. One is of formula EX5 and the other one is of formula EX3. Okay. But nitrogen, they will not form +5 oxidation state. No. So they will not react with the halogen to give EX3. That is NCl3, NF3 type is not possible. Okay. The reason is the unavailability of d orbital. The reason is the unavailability of d orbital. Since there is no d orbital present for nitrogen, there are only 2s and 2p orbital, no 2d orbital. So maximum nitrogen can form only 4 bonds. That's what we have already studied. No? Maximum covalency is 4 for nitrogen. So it cannot take 5 as its covalency. Okay. So it is not there. So 5 bonds cannot be formed using nitrogen. It cannot expand it often. Now pentahalides are more covalent than trihalides. For the other elements, from phosphorus till bismuth, they will form pentahalides. No? So they are usually more covalent. Like if PCl3, if I'm comparing PCl3 and PCl5, pentahalides are more covalent. PCl5 is more covalent. In PCl5, the oxidation state is +5. In PCl3, the oxidation state is +3. So the one which is having the highest oxidation state is more covalent in nature. So this concept you might have studied in your class 11 chemical bonding under Pajan's rule. Right? So you can see now here the element is in +3 oxidation state. Here in +5 oxidation state, means the size of the ion is very small when the charge is more. So the one which is bigger in size is have less polarizing power, and the one which is smaller in size is having more polarizing power. So what happens? The +3 oxidation state containing element will be forming bond like this, and +5 element is like this. So here you can see the bond is not formed that much, but here bond formation occurs. So +5 is more covalent compared to +3. Okay. If the charge is more, covalent character is more. Okay. Charge is directly proportional to the covalent character. This is one among the 3 rules of Pajan's. Okay. In class 11, you might have come across this as a second rule under that. Now, Pajan's rule predicting the covalent character, some more concept I'll tell you. Okay. Now here in this picture you see anion is same. Anion is same. cation size is increasing. Cation size is increasing. So just remember one thing, size of the cation is inversely proportional to the covalent character. Okay, means the one which is having the smaller size is more covalent in nature. Now you can tell me which is more covalent. The first compound. The first compound is more covalent. Covalent character increases from top to bottom. So the first compound is more covalent in nature. Okay. Now here you see in the second system, cation is same. Cation size, both yellow color cation size is same, but anion is differing. Green color anion is smaller than brown color anion, right? Size of the anion is directly proportional to covalent character. Means the one which is having the largest size is more covalent. So which is more covalent? So this anion is having bigger size, so this compound is more covalent. So covalent character increases from top to bottom. Okay, so this relation alone you study. You don't have to confuse with anything. Okay, this relation you study. Size of the cation is inversely proportional. Size of the anion is directly proportional. Charge is directly proportional to covalent character. These three rules you study. These three are the Fajans rule. Okay. Now let's go with the halides of this group elements. So these are the halides with the +3. Now the polarizing power. Let me erase this. Yeah. The polarizing power decreases from top to bottom due to the increase in the atomic size. Now only I have told you, no, if the size is very small, polarizing power is more. So nitrogen is having very small size compared to bismuth. So nitrogen is having high polarizing power, and that power decreases from top to bottom. Okay. So because of that, covalent character also decreases. Covalent character also decreases. So NX3 is more covalent, BiX3 is less covalent. So these are the halogens, fluorine, chlorine, bromine, iodine, and astatine. So all these group 15 elements can form the bond with all the halogens which are here in the table. And moving from top to bottom, the size of the halogen, or I can say the anionic size, halogens always form anions, right? So anionic size increases. So the ease of polarization also increases. So the covalent character also increases. Okay. So now from this, let me conclude one statement. BiF3 is an ionic compound, whereas BiI3 is a covalent compound. BiI3. Here you see in both the compounds, bismuth is same. Bismuth is the cation. So which case we have to take? If this is case 1 and this is case 2, this particular system will fall under case 2. Because in both the compounds, bismuth is the cation and it is same. Anion is differing. In the first case, it is F minus, and the second case, it is I minus. This is F minus, I minus. Now, I have already told you, no, anionic size is directly proportional to covalent character. Okay, comparing this F and I is having the bigger size, so it is a covalent compound, but BF3 is an ionic. Got it? I hope this concept is clear to all of you. Just study the 3 rules alone. Don't get confused. And talking about this nitrogen halide, only NF3 is known to be stable. Only NF3 is known to be stable. NCl3, NBr3, they are all unstable only. Only NF3 is known to be stable. Okay, due to the small size of nitrogen as well as the small size of fluorine. Got it? So I'll close today's class with a question for you from the concept which we have discussed only. Okay. So here is the question to all of you. Why is bismuth hydride a strongest reducing agent among group 15? I told you, no, while discussing the reducing nature, I told you there will be one question at the end for all. Can you give me the answer? Reducing. Why BaH3 is more reducing compared to NH3PH3? I'll give you 15 seconds. Think for it and give me the answer. First. It can easily lose. Yeah, very good, Navya. It can easily lose hydrogen because it is the bond length between bismuth and hydrogen is very high, like more bond length. So bond strength is very less. So it can easily be broken. They have the longer bond length. Yeah, they have the same picture we have already studied. Longer bond length. So the overlapping is very weak. So the extent of overlapping decreases and bond length increases. And because the bond length is increasing, the ease of the removal of hydrogen, the ability, ease means ability, okay? Ability to remove the hydrogen increases on moving down the group. So that's why the reducing nature decreases. Okay, fine. And one more question. Explain why NH3 is basic while BH3 is feebly. Feebly means slightly basic. For this also we have already seen the explanation. In case of NH3, electron density is more because of the small size of nitrogen. Whereas in BH3, because of the large size of bismuth, electron density is very less. Okay, so NH3 is acting as a strong base. Because of the less electron density, BH3 is acting as a weak base. Okay, so this is enough for today. I hope this is clear to all of you. And the next class, yeah, bond angle. So I'll just skip this question. You can try for it. And in the next class, we can start with the anomalous behavior of nitrogen, and it's very simple and small only. We'll complete this and go for the next group. Group 16, we will check. Okay. So if you have any doubts, you can ask me. If there are no doubts, you can leave the class, students. Thank you for listening the class. You can take down this question, okay, and go through the part later. So study till what we have discussed today, okay, till the chemical properties of nitrogen and its group members you study and come. So thank you so much. Bye-bye. Take care. Yeah, thank you.